We're having a look at worksheet number 2 here, questions 4, 5, and 6. Question number 4 says a 1200, this should say a 1200 kilogram car accelerates from rest to 10 meters per second in a time of 4.50 seconds. We want to find that the force that the car's tire exert on the road. This is an impulse question. We have a force and a time. And listen, when a question says what's the impulse, it's obvious that it's impulse, right? When a question has a force and a time, that's a pretty good indication that you should try impulse as well. This has a force and a time, so let's do impulse. We got a mass here of 1,200 kilograms. We got a initial velocity of 0 meters per second, and we have a final velocity here of 10.0 meters per second. Now, we don't really know which direction it's moving in, but we know it's in the positive direction. We're defining whatever direction it is as the positive direction. So it's just positive 10. My time interval is 4.50 seconds. And we want to find the force. Now, somebody this morning asked a question, not with regards to this question, but it was a similar type question. Said, listen, should we find delta P using this equation and then set that value that we solve for equal to this equation? And the answer to that is yes, that's good. But we can also combine those two equations. They're already combined on my data sheet. And just use them together. Solve for F here. We get m times delta V. F is multiplied by T, so we're going to take it over to the other side by dividing. We end up getting 1,200 kilograms times delta V is 10 minus 0, divided by 4.50 seconds. And when I do that math, I end up getting 2.67 times 10 to the 3 newtons. I'm not sure who asked me for number 4 there, but is it okay? Yeah. Okay, let's go to number 5 then. This one says a 1,500 kilogram car traveling at 80 kilometers per hour. So I want to right away draw attention to that. Comes to a screeching halt. What does that mean? Comes to a screeching halt. Stops. So that means VF is going to be equal to 0, right? Time of 4 seconds. What's the force of friction? This is a similar question. Once again, we have a force and a time. Force of friction, time, think impulse. M is 1,500 kilograms. We're going to say VI is 80 kilometers per hour. What's the shortcut for converting that to meters per second? Yeah, so that gives me 22.2222 meters per second. My time interval here is 4.00 seconds. We're looking for this. Oh, VF is 0 as well. So once again, we're going to say F times T is equal to M times delta V. Solve for F. Just like in the last question, it's M delta V over T. I mentioned this yesterday, or 2 days ago, I should say, but I'll mention it again. Be careful when you're writing this impulse equation out that you make it M times delta V. Hey, one of the things that people like to do is call it M times V. F times delta T, or F times T, is equal to M times V. It's not M times V. That's momentum. Yeah, it's the momentum at one moment in time. We're talking about the momentum change or the impulse here. So you got to have that delta in there. So what do we got here? 1,500 times delta V, which is 0 minus 22.222, divided by my time interval, which is 4.00 seconds. And when I do the math there, it works out to be negative 8.33 times 10 to the 2. Do you guys see that it's negative? It means it's a force is opposite to the way that it was moving? Should be, right? If it's moving to the right, then the force of friction should be to the left. If the car was traveling to the left, the force of friction should be to the right, opposite to the way that it was moving. We made it positive the way it was moving, so the force of friction should automatically work out to be negative. And 6, a 1 kilogram ball traveling towards a soccer player at a velocity of 5 meters per second rebounds and off the player's foot at a velocity of 8.5 meters per second. I'm going to circle this. I'm just going to write a little note to myself about positive and negative. The whole rebounding thing. I don't know which one I want to make positive, which one I want to make negative, but I know that if the soccer ball is traveling one way and then it's traveling the other way, one of them has got to be positive and one of them has got to be negative. Doesn't really matter which one. Time of contact, what's the magnitude of the force? Mass is 1 kilogram. I'm going to say VI. VI, I'm going to say, is negative 5.00 meters per second. So I'm going to say towards me is negative, away from me is positive. You could very easily define it the other way around. VF, as it's going away from me, will be positive 8.50 meters per second. If you defined it the other way around, we would have plus 5 and negative 8.5. Time of contact. And we're looking for the force of friction here. So once again, for the third time in a row, we could say m times delta V, F times delta T, solve for F. Uh, 1 kilogram times, this one's going to be 8.50 minus negative 5. And that gives me 675. If you did it the other way, 5 and negative 8.5, then you would have got a force of negative 675. Bottom line is, if it's moving towards you, the force has to be away from you to cause it to change direction. But bottom line is, we're looking for the magnitude, so that force should be positive anyways. Even if you get a negative, you should drop that negative. Is that okay? Any questions on those? Okay, I want to do one more little thing just with regards to momentum, or impulse, I should say, and then we'll finish our little egg drop competition from yesterday, all right? What I'm about to do is something that you could maybe handle already. This is not something that's brand new. This is not a new concept. It's just a little tweak on one specific type of impulse problem. Sometimes you got a situation where we're analyzing a problem where two objects hit each other. Now, I don't know if you remember this, but in Physics 20, you had a question on your test, on your dynamics test. I don't know whether you were in my class or Mr. Coderre's class, you had the same question. And the question was a multiple choice question, and it was something to the effect of, how do the forces compare when a mosquito gets splatted against a moving semi-truck? What's the answer to that, Eric? The forces are equal and opposite. The forces have the same magnitude, right? We know from Newton's third law, if object A applies a force on object B applies an equal and opposite force on object A. Didn't matter how fast the bug was moving. Didn't matter how heavy the bug was. It didn't matter how fast the truck was moving or how heavy the truck was. In the end, the bug was way weaker than the truck, and that's why the bug splattered. It didn't splatter because it experienced more force than the truck experienced. The truck experienced just as much. It just didn't have the braking strength that the bug did. It was a lot easier to break the bug than it was to squish the bug than it was to squish the truck. Well, the same thing applies with impulse. If the bug lost a certain amount of momentum, then the truck would have gained the exact amount of momentum that the bug lost. So in other words, the impulse experienced by the bug would be equal and opposite to the impulse experienced by the semi-truck. Does that make sense? If you're running and you collide with somebody else and you lose momentum, that other person gains momentum, the exact same amount. If object A applies a force on object B applies an equal and opposite force on object A. But if object A experiences a certain impulse, then object B will experience an equal and opposite impulse. Really, it's just another way to state Newton's third law. We derive the equation for impulse using Newton's second law, but this whole impulse/collision thing is Newton's third law. When we have two objects that collide, the momentum gained by one, or the impulse, will be equal and opposite to the impulse experienced by the other one, regardless of whether one's a bug and one's a semi-truck, or whether we've got two cars that are exactly the same mass and exactly the same speed. One thing you got to be careful of when you're dealing with a problem like this is that when you have two objects, the temptation is to use data for both of them. So let's say let's deal with that bug in the semi-truck again for a second. I have the initial velocity of the bug and I have the final velocity of the semi-truck. Well, Okay, I got a VI and I got a VF. Let's use it. You can't do that. In a situation like this, even if you have two objects, you got to pick one. Go with it. Either use the mass, initial, and final velocity of the bug, or, but not and, or use the mass, the initial, and the final velocity of the semi-truck. Use data for one of them, but not both of them. You can't mix and match. That's the one real big thing you got to be careful of with those problems. Pick data for one. You will have a couple months from now a written response test. On that written response test, there'll be a question that involves a collision between two cars. And there's lots of things that you have to calculate from that, some of which you haven't even learned about yet. But one of the things that you're going to have to calculate is the force of impact on one of the cars. It is so tempting when you're solving that problem to use velocities that are given to you in the question. But the reality is, you can't do that, because the reality is you have given to you the velocity, the initial velocity of one car and the final velocity of the other car. You've got to get the initial velocity and the final velocity of the same car and then do impulse. Okay, when you're looking for a force of impact, do impulse, that's great, but pick one car or the other, not both. I say that, I'm warning you now, but 2 months from now when you guys write that written response test, some of you are still going to make that mistake. Hey, remember this moment. Remember this moment when you're writing that test, and don't make that mistake. Okay, I want to do one example, and then we're going to call it a day other than dropping our eggs here. The example is on the handout that I gave you the other day. It's the last one on the page. And it looks like this. It says at the top of the page, C13 example problems. It says a 1,200 kilogram car traveling north at 10 meters per second collides with a 1,000 kilogram car traveling south at 10 meters per second. The two cars entangle. What does entangle mean? When two things entangle, it means they're together and they head off together. So they head off as one velocity of 0.901 immediately after the collision. So in other words, both of them have that velocity because they're going off together. The collision lasts for 0.08 seconds. What's the force of impact on the lighter car? What's the force of impact on the heavier car? This is going to be the lighter car in blue, and the heavier car is going to be in green. We're going to say the mass of the lighter car is 1,000 kilograms. We're going to say the initial velocity of the lighter car, we're going to say VI, is equal to negative 10 meters per second because it's to the south. And we're going to say that the final velocity of the lighter car is positive 0.901 because it's going to the north. The time of impact on both cars is 0.0800 seconds. If I collide with you for 0.08, then you collide with me for 0.08. What's the force of impact? We're going to say F is equal to M times delta V over delta T. 1,000 times 0.901 minus 10. When we do that, what do we get? 1,000 times divided by 0.08, 1.36 times 10 to the 5. Good? Is that what you guys get? Cole, did you get that when you punched it in? Did anybody else punch this in? Maybe I'm wrong. Maybe I made a mistake. All right, let's, you know what, let's try the force of impact on the heavier car now. Once again, F is equal to M times delta V over delta T. The mass of the heavier car is 1,200 kilograms times VF minus VI. VF is 0.901, and the initial velocity of the heavier car is positive 10, divided by delta t, 0.080. Okay, I'm not even going to use my calculator for this one. This is how good I am. Okay, lightning fast calculation in my head here. 1200 times 0.901 minus 10, carry the 1. I'm going to make it negative 1.36 times 10 to the 5. Anybody get that? Boy, that was impressive, wasn't it? How did I know the answer was negative 1.36 times 10 to the 5? The impulses have to be equal and opposite, right? If you get a question like this, you get two options. You can solve for the first one, the blue one here, and then just say the green one is negative of that. But if you got time, and you will have time this year on your diploma exam, I guarantee you're going to have time this year on your diploma exam, then check it. Double check it. Double check it by calculating the second one. If you get the same answer, you're right. Like it is guaranteed to be correct. If you get two different answers, then you are guaranteed to be wrong. And you got to try again.